solving for areas, if we have a rectangle, let's say this is 4 and this side is 10, area is simply equal to length times width. So we've got 10 times 4. Your area for this rectangle is 40. If we have a triangle here, let's see, let's call this 6, let's call this 4. And let's just assume it's a right triangle. Area is equal to 1/2 base times height. Well, we've got a base of 4 and a height of 6. 4 times 6 divided by 2 is equal to 12. Suppose we have a circle with a radius of, let's call it 5. Area for a circle is pi r squared. So area is equal to 25 pi. Or if you want to multiply out the pi, you'd get 78.5, roughly rounded. If I wanted to know the circumference of this, circumference is going to be equal to, let's call this diameter is 10. If the radius is 5, then the diameter is 10. Circumference, so you can use 2 pi r, or pi times the diameter. Pi times the diameter, if our diameter is 10, the circumference is equal to 31.4. So those are fairly simple reviews. The next problem on your packet, number 3, says complete the equations for the following. It has A, B, and C. Cosine of theta equals, sine of theta equals, and tangent of theta equals. I would venture a guess to say that most of you have not been exposed to this form of trig. So you could probably pick this up pretty easily, and I'll explain it now. So for any right triangle, we have these functions that will work for any right triangle. And before I go any further, I know your worksheet that you're working on has it organized like this, where the cosine is first. I'm going to go ahead and switch up sine and cosine. And the reason that I do that is a common thing you'll hear people say is SOHCAHTOA. When we're dealing with trigonometric functions and right triangles, we'll use the term SOHCAHTOA. And written out, that looks like this. SOHCAHTOA. And what this means is, SOHCAHTOA means sine is opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. It's a way people remember this. And I would also probably put equal signs in here. Equals, equals, equals. It's just a way of remembering it. Sometimes it works for people, sometimes it doesn't. So let's kind of figure out what we're really talking about here. Again, this is pronounced sine, not sin. If we look at our right triangle, we know, this is our 90. We know that there's some angle here. We're going to define it as theta. This symbol is theta. So it's whatever angle it happens to be. And we have a side A, a side B, and a side C. Now, A is, A is in reference to theta. A is the opposite side. We'll use OPP for opposite because it's opposite the angle. B is the adjacent side. We'll use ADJ for adjacent. And C is our hypotenuse. We should know this about right triangles. C is your hypotenuse. So for sine theta, what does sine theta equal to? It's equal to our opposite, which is A, over our hypotenuse, which is C. So sine theta is A over C. Cosine theta is adjacent B over hypotenuse C. And tangent is your opposite A over B. Going along with this would be the Pythagorean theorem. Pythagorean theorem states that A squared plus B squared equals C squared, or your opposite side squared plus your adjacent side squared equals your C squared. Now, keep in mind, we can put numbers to this, and sine is just a function on any scientific or graphing calculator, and we'll show you how to do that. So let's say I have a triangle here where the triangle has a 25-degree angle and the opposite side of that 25-degree angle, so A is equal to 12, and I want to know what B and C are. I want to know what B and C are. Well, one way to solve for C or B is to use our trigonometric functions. So let's solve for B, and solving for B, we would need to know that the tangent of some angle theta is going to be equal to the opposite side of that angle, opposite over opposite over adjacent, not hypotenuse, over the adjacent side. Okay, so we know our angle, so tangent theta is tangent of 25 degrees. That's equal to the opposite side, which is 12, over the adjacent side, which is B, unknown. Don't know what B is, but I can solve for B. And here's how we deal with this. We take tangent of 25 and we calculate that. We punch that into our calculator. So we go to our scientific calculator and we look for our tangent button, okay? Our tangent button, and we make sure we're in degree mode for now. Okay, we're going to make sure we're in degree mode. Tangent of 25 degrees, close parentheses, is equal to, let's round to the third digit, 0.466. 0.466. So 0.466 is equal to 12 over B. Now we've got an algebraic expression where we're solving for B, and we can cross multiply this, multiply both sides by B, and then divide by 0.466. So we're left with solve for B. B is equal to 25.8, rounded, 25.8. Okay, so we solved for B, and we solved that B is equal to 25.8. The other thing, and now we can solve for the hypotenuse by using Pythagorean theorem. A squared plus B squared equals C squared. plug in your numbers, solve for C. 809.64 equals C squared. Taking the square root of both sides tells us that C is equal to 28.5, rounded. 28.5. So this is equal to, let's make this blue, 28.5. Another way we could have found C is that we know what our opposite side is, and we know that another equation we have, another tool we have, is that the sine of theta is equal to our opposite over hypotenuse. Okay, we've already solved for C, but let's just you know, see if we didn't solve for C and use the sine function instead of the Pythagorean theorem to solve for C. So C would still be our unknown in the equation. We'd have sine of 25 equals opposite. Our opposite side is 12. The hypotenuse is C, the unknown, and we're going to solve for C. Sine of 25, and again we're going to stay in degree mode. Sine of 25 is equal to 0.423. So we'd have 0.423 equal to 12 over C. And if we solve for C, cross multiply that, we'd have 12 divided by 0.423 is equal to, rounded, C would be equal to 28.4. Pretty close. Okay, rounding kind of gives you slightly different answers, but that's not much different. Okay, that's pretty close. We've proven that the sine function can work just as well as using the Pythagorean theorem in this case. And just as another exercise using the cosine function, we know that cosine of theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse. So cosine of 25, that better be equal to my adjacent, 25.8, over my hypotenuse, which is 28.5. So we want to make sure that cosine of 25, and this is, again, just another exercise. You don't have to do this. We're just kind of going through, just playing with the cosine, sine, and tangent function to make sure you get comfortable use of it and understand what it actually is. So cosine of 25, we're saying, should be equal to, it should be 25.8 divided by 28.5. Well, 25.8 divided by 28.5 is equal to 0.905 with some other numbers. So cosine of 25 better be equal to that. If I punch this cosine 25 into a calculator, I hope that I will get that. Let's see. Cosine of 25 equals 0.906. We were predicting that it would be 0.905. We're off by a hundredth, I'm sorry, a thousandth of a decimal, which is pretty close. We're pretty good. If you work these equations for the other angle that's in this triangle, so there's another angle in this triangle where this angle, because inside of a triangle, we better get 180 degrees. So if this is our 90 degree, so if this is 90, and this is 25. That tells us that this other angle is equal to 65 degrees. This angle is 65 degrees. Now, play with the numbers using 65, except now B becomes the opposite side, and A becomes the adjacent side for using the 65 degree. C is still your hypotenuse. You can try out the sine, cosine, and tangent functions. See if you don't come up with the same numbers using 65 degrees as your angle, where B would now be the opposite side, A would be the adjacent side, and C is still the hypotenuse. Last exercise I want to do involves complementary angles and other angle rules that you should remember from geometry. Uh, so if I have an angle here, if I have a line drawn through two parallel lines, if I measure this angle here, all right, I measure this angle, this is about 60 degrees from here over. From my 0 line up, this is 60 degrees. From this 0 line over, we've got 120 degrees. Okay, 120 degrees. So this is 60. And by rule, this has to be 120. And we've measured that, and we know it's 120 by our measurement, but the reason we know it would have been 120 anyway is because 60 plus 120 is 180, and a straight line makes 180 degrees. There's another rule that says these interior angles should be equivalent also. So if this is 60 degrees, this thing should be 60 degrees. And this thing should be 120 degrees. And if we take our protractor and we put it on our line, and let's rotate it around, we can see that, in fact, we have from this 0 line 120 degrees, and from this 0 line 60 degrees. The next thing that we need to know is that this angle here, if these are both parallel lines, this angle here must also be 60 degrees, and therefore this angle must also be 120 degrees, and this angle must also be 60 degrees, and this angle must be 120 degrees, because these are parallel lines. Let's move our protractor to prove that that's true. We measure it, and in fact, we do get 120, 60, and rotating this puppy around, we get 120 from this, and 60